A NEMA L5-30R receptacle is specifically rated for 125 volts, 2-pole, 3-wire grounding. The 2-pole description in this context refers to the configuration of the plug and receptacle, not necessarily requiring a 2-pole breaker. The voltage rating is the critical factor for determining the correct breaker and wiring. In this situation, the contractor incorrectly wired the receptacle for 208 volts using a 2-pole breaker, which resulted in damage to the UPS. The core issue is the voltage mismatch. The L5-30R receptacle is designed to receive 125 volts. Supplying it with 208 volts is a significant overvoltage condition that can damage or destroy connected equipment. The fact that the panel schedule showed 2 poles is irrelevant to the voltage requirement of the receptacle. Panel schedules indicate the breaker configuration, not necessarily the voltage supplied to each circuit. The UPS was designed to operate on 125 volts. When it received 208 volts, its internal components were subjected to excessive electrical stress, leading to failure. Electrical codes and design plans are crucial for ensuring safe and proper installations. Design plans specify the required voltage, receptacle type, and breaker size for each circuit. Electrical codes provide guidelines for safe wiring practices and component selection. In this case, the design plans specifically called for L5-30R receptacle, which implies a 125-volt circuit. A qualified electrician should have recognized the voltage requirement and installed the appropriate breaker and wiring. Using a 2-pole breaker does not automatically mean that the circuit is supplying 208 volts. 2-pole breakers can be used in 120/240 volt single-phase systems or 208 volt 3-phase systems. The voltage supplied to the circuit depends on how the breaker is connected to the electrical panel. In a 120/240 volt system, a 2-pole breaker connects to both hot legs of the single-phase supply, providing 240 volts. However, a single pole of the same breaker can be used to provide 120 volts to a separate circuit. In a 208 volt 3-phase system, a 2-pole breaker connects to 2 phases of the 3-phase supply, providing 208 volts. However, the L5-30R receptacle is not designed for this application. The correct installation for a L5-30R receptacle requires a single-pole 125-volt breaker connected to a single hot leg and a neutral conductor. This provides the required 125 volts to the receptacle. It's important to verify the voltage at the receptacle using a voltmeter before connecting any equipment. This ensures that the receptacle is wired correctly and that the equipment will receive the correct voltage. If the voltage is incorrect, the wiring should be corrected immediately. Electrical safety is paramount. Incorrect wiring can lead to equipment damage, electrical shock, or fire. Only qualified electricians should perform electrical work. They have the training and experience to ensure that electrical systems are installed safely and correctly. Several factors are essential for preventing similar incidents in the future. Firstly, always follow design plans and electrical codes. Secondly, verify the voltage at the receptacle before connecting any equipment. Thirdly, use qualified electricians for all electrical work. Fourthly, provide clear and accurate labeling of circuits and receptacles. Fifthly, train personnel on proper electrical safety procedures. These measures can help prevent electrical accidents and ensure the safe operation of electrical equipment. Regarding the damaged UPS, it is important to have it inspected by a qualified technician to determine the extent of the damage. The technician can assess whether the UPS can be repaired or if it needs to be replaced. It is also important to investigate the cause of the overvoltage condition to prevent future incidents. This may involve inspecting the electrical panel, wiring, and breakers to identify any faults or misconfigurations. Remember that electrical systems can be complex and dangerous. Always exercise caution and seek professional help when working with electricity. This specific situation highlights the importance of understanding voltage requirements, proper wiring techniques, and the role of qualified electricians in ensuring electrical safety. When dealing with electrical installations, understanding the NEMA standards for plugs and receptacles is crucial. NEMA, the National Electrical Manufacturers Association, sets standards for electrical connectors used in North America. These standards define the physical configuration, voltage, amperage, and grounding characteristics of plugs in receptacles. The L5-30R is just one of many NEMA configurations, each designed for specific applications. The L in L5-30R indicates that it is a locking type connector, which provides a more secure connection than a straight blade connector. The 5 indicates the voltage rating, which in this case is 125 volts. The 30 indicates the amperage rating, which is 30 amps. The R indicates that it is a receptacle. The corresponding plug for this receptacle is a NEMA L5-30P. Other common NEMA configurations include 5-15, 5-20, L6-20, and L40-30, each with different voltage, amperage, and grounding characteristics. It is important to select the correct NEMA configuration for the application to ensure compatibility and safety. Using the wrong type of plug or receptacle can lead to equipment damage, electrical shock, or fire. Understanding the different types of electrical systems is also crucial for proper installation and troubleshooting. The most common types of electrical systems in North America are 120/240 volt single-phase and 208 volt three-phase. In a 120/240 volt single-phase system, the voltage between the two hot legs is 240 volts, and the voltage between each hot leg and the neutral is 120 volts. This type of system is typically used in residential and light commercial applications. In a 208 volt three-phase system, the voltage between any two phases is 208 volts. This type of system is typically used in commercial and industrial applications. It is important to identify the type of electrical system before installing any electrical equipment. Connecting equipment designed for one type of system to another type of system can result in damage or failure. In the case of the L5-30R receptacle, it is designed for use in a 120 volt system. Connecting it to a 208 volt system, as the contractor did, is a serious electrical hazard. It's also important to understand the role of grounding in electrical systems. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock and fire. All electrical equipment should be properly grounded. The grounding conductor should be connected to the equipment grounding terminal and to the grounding electrode system at the service entrance. In the case of the L5-30R receptacle, the grounding conductor is the third wire in the 3-wire configuration. This wire should be connected to the grounding terminal in the receptacle and to the grounding system. Proper grounding is essential for electrical safety. Another critical aspect is the selection of appropriate overcurrent protection devices, such as circuit breakers and fuses. These devices are designed to protect electrical circuits from overloads and short circuits. The size of the overcurrent protection device should be matched to the ampacity of the circuit conductors. Overcurrent protection devices should be installed in all electrical circuits. In the case of the L5-30R receptacle, a 30 amp circuit breaker should be used to protect the circuit. The circuit breaker should be installed in the electrical panel and connected to the circuit conductors. Regular inspection and maintenance of electrical systems are also essential for safety and reliability. Electrical systems should be inspected periodically by a qualified electrician to identify any potential problems. Maintenance tasks, such as tightening connections and replacing worn components, should be performed as needed. Regular inspection and maintenance can help to prevent electrical accidents and ensure the safe operation of electrical equipment. In addition to the technical aspects, it is also important to consider the legal and regulatory requirements for electrical installations. Electrical work is typically regulated by local and national electrical codes. These codes specify the requirements for electrical installations, including wiring methods, component selection, and safety procedures. The electrical work should be performed in accordance with these codes. In many jurisdictions, electrical work must be performed by licensed electricians. Licensed electricians have the training and experience to ensure that electrical systems are installed safely and correctly. It is important to verify that the electrician is licensed before hiring them to perform any electrical work. In summary, the situation with the NEMA L5-30R receptacle highlights the importance of understanding voltage requirements, proper wiring techniques, NEMA standards, grounding, overcurrent protection, electrical codes, and the role of qualified electricians. By following these guidelines, electrical accidents can be prevented and electrical systems can be operated safely and reliably. Remember to consult with a qualified electrician for any electrical work, and always prioritize safety.